Good morning, students. In today's class, I will explain another unique feature of C++ language called reference variables. In our last class, we learned about the need for on inline functions. What are inline functions? Inline functions are those functions which, when we call them, the code associated with that particular function is copied into the place in the calling function. So wherever in the calling function you call that function, automatically the entire code associated with that particular function will be copied. So the main advantage of inline function is it avoids function overhead time. So generally, when you call a function, in the last class I already explained, lot of changes will take place. The control has to stop at the calling function. The control has to go to the called function. Then after completing the work, the control has to return back to called function, calling function. Then it has to go to stack register to fetch the value of actual argument. All these things take a lot of time. But when you make the function of inline function, such overhead is completely avoided because at the time wherever you call that function, the code only the called function code only will be substituted in the calling function. We also studied the advantages and disadvantages of inline function. Inline function increase the speed of the execution and it also avoids the function overhead time. On the other hand, an inline function suffers from one major drawback. The reason is internally it increases the size of the program because whenever you call it, the code has to be substituted. No, so when you call that function more number of times, means every time when you call that function, the code will be replaced. So naturally, it increases the size of the program. So this is the main drawback of an inline function. We also studied some restrictions on making the function as inline. The thing is only small function where the computational time is very much less can be made as inline function, and with the restriction that inline function cannot be recursive function. Inline function should not contain any looping statement, go to statement, switch statement, etc. In today's class, we'll be learning about another unique characteristics of C++ language called reference variable, where reference variables are used, and what is the difference between a pointer variable and a reference variable. At the end of today's class, you will be understand the purpose of reference variable, why and what are the uses of reference variable, and the major difference between a pointer variable and a reference variable. Because in your C language, you already studied what is a pointer, etc. So in today's class, after learning reference variable, you will understand the difference between a pointer variable and a reference variable. To understand what is a reference variable, let us consider a simple example, simple declaration statement like int a equal to 5. So this declaration you already studied in your C language. Once you declare such variable, what happens is the compiler reserves one memory location and the memory location is identified as a, okay, and it has some address say 1000 and the value 5 is stored in that memory location which is created for a. So the declaration int a equal to 5 automatically creates a memory location of 2 bytes or 4 bytes depending on the word size of the machine, and the memory location is labeled with the name of the variable. Here it is a, and every memory location has some unique address. Say for example, in this case, let the address be 1000 and the value 5 is stored in that particular location. But we know that every memory location should have a unique name. So once the memory location 1000 is identified with the name AME, then what happens is same memory location cannot, some other variable cannot have the same address. So every memory location has a unique address and also has a unique name. The question is, suppose the memory location 1000 in this case, I want to call it by another name. That means for the same memory location, I want to give one more name. Is it possible or not? Generally, in C language, it is not possible because every memory location should have a unique name and a unique address. But in C++, when flexibility is there, a same memory location can be called by multiple names. So here the original name of the memory location is A. Now what I'm doing is the same memory location A is referred by two more variable names called B and C. So now the memory location address remains as 1000. The original name of the memory location is A and the value is 5. Now what I'm doing is the same memory location with the address 1000 with the name A. I will try to call or I'll try to rename with two more names called B and C. Now what happens is A, B, C all refers to the same memory location 1000 and the value is 5 only. Here the original name is A, but it has two more names called B and C. Here, B and C are nothing but alternate names for A, or it's also called as alias for A. Alias means a different name. The memory location which is identified with the name A now can be called by some other name. The alternate name we call it as an alias. So such variable which are alias for the original variable are called as reference variable. So in this example, the original variable name is A. Now the A is called by two different names called B and C. In this case, we say that B and C are the reference variable for A only. So in case of reference here, what happens is the variable and all its references will points to the same memory location. In this case, the address of A is 1000 means the address of B and C, which are the references for A, is also 1000 only. So the references cannot take another different address. That is the main intention of reference variable. A reference variable is one which is an alias or alternate name for some other variable. And the original name variable and all its reference points to the same memory location. In case of reference variable, the compiler will not allocate extra memory for the reference variable because the reference variable also points to the same memory location as that of the original variable. Let us see what are some of the important characteristics or facts about a reference variable. One is one variable can have any number of references. There is no limitation on the number of reference variable for a particular variable. In this example, the original variable is A. In this case, I have given two more references for A only. So B and C are the reference variable for A. Instead of B, C, you can have B, C, D, E, F. You can have 100 reference variable for the original variable E. But one variable can have any number of references. But one reference variable should be a reference variable for one and only one variable. In the previous example, since B and C are the reference variable for A means B throughout the program, B should be reference variable for A only. B cannot be the reference variable for another variable. Similarly, C also is a reference variable for A means C also cannot become the reference variable for any other variable. One variable can have any number of references, but one reference variable must be the reference variable for only one variable. Since the variable and all its reference variable points to the same memory location, if the value of the original variable gets altered, means the value of all its reference variable also gets altered. At the same time, if one of the reference variable value is altered, means the original variable and all the remaining reference variable also gets altered. Next, how to declare a reference variable. The general syntax of declaration of reference variable is first you mention the data type, just similar to your normal variable. Data type, normal variable, you are not starting with the and sign, but the reference variable should be started with the ampersand sign. So any variable prefixed with ampersand sign indicates that it is a reference variable. Similarly, any variable prefixed with a star mark denotes it's a pointer variable. So the general syntax is data type ampersand reference variable equal to the variable. That variable indicates the original variable name. For example, in ampersand B equal to A means A is a normal variable and B is its reference variable. Now what happens is A and B points to same memory location, comma, ampersand C equal to A means C is also another reference variable for A only, and ampersand D equal to A means D is also a reference variable for A only. So in this example, the variable A has three reference variables B, C, D. The meaning is the A can be called with either A, or can be called with B, or can be called with C, or can be called with D, because all are the reference variable for A only. So here A is a variable, B, C, D are the reference for A. So in this example, the variable A has three reference variables. Instead of three, you can have 10 also, no problem. But B, C, D are the reference variable for A means throughout the program, they must be the reference variable for only A. They cannot become the reference variable for any other variable, say X. Let us illustrate the usage of reference variable with a simple example program. So here int A equal to 10 means we are declaring a variable called A with a value 10, comma, ampersand B equal to A means B is a reference for A, C is a reference for A, and D is also a reference for A. Now the variable A has three references B, C, D. Now first line, see out A, B, C, D. Display means the original value of A means B, C, D also must be A only. The output will be 10, 10, 10, 10. Next, I'm incrementing the original variable. So A plus plus means A becomes 11. When the moment A becomes 11 means, as already told, whenever a variable gets altered, all its reference gets altered. Whenever any one reference gets altered, all the remaining references and the original variable gets altered. So here A plus plus play increments the value of the original variable by A by 1. So now A becomes 11 means naturally B, C, D also becomes 11. Then the second output would be 11, 11, 11, 11. Now what happens? All A, B, C, D, the current value is 11. Now I'm incrementing C++. That means I'm changing the value of the one of the reference variable C by 1. So already C has become 11 means now C becomes 12. When C becomes 12 means naturally A, B, D also becomes 12. So in the third cout statement, the output will be 12, 12, 12, etc. So this is the main utility or main usage of reference variable. A reference variable is nothing but giving or calling a memory location by different names. You can either use the same, you can use the original variable, or you can use its reference variable. It points to the same memory location and the purpose is one and the same. Let us see. In your C language, already studied call by value, call by reference, etc. So in today's class, I will explain again what is the meaning of call by value, call by reference, and the usage of reference variable with one more example program. So void main int A equal to 10, B equal to 20 means there are two variables A and B with the value 10 and 20. Now we'll write a prototype void swap1 int comma int. That means the variable swap1 takes two arguments of integer type and does not return any value. The return type is void. Now see out A set W4B means first you display the value of A, then it becomes 20. Then you display the value of B by giving a width of 4, because the reason is to get in order to display here I am displaying the value of A and B with some little separations. So the output will be 10 and 20. So here A value is 10 and the B value is 20. This is for this cout statement. Now call the function swap1 with the values of A and B. So the control jumps to here. So here I made one mistake here. It should be int A and int B. Okay. Now you declare a temporary variable called A, T, exchange the values of A and B and come back and again display the value of A and B. It will again 10 and 20. The reason is in call by value, the value of the actual argument goes to formal argument, and any changes to formal argument inside the function has no effect on the actual argument. So here inside the function a and b gets altered. That means this a and b, here a and b I'm using, they are formal argument. Any changes to formal argument has no effect on the original argument. Means again the value of a and b in the calling function will be 10 and 20 only. Next, second one is call by reference. In call by reference, the formal arguments are pointer. The actual arguments are the address of the variable. In the previous example, in call by value, formal arguments are also variable. Actual arguments are also variable only. That's why I mentioned it as int comma int. Whereas in case of call by reference, actual arguments are normal variable and the formal so actual arguments are the address of the variable and the formal arguments are the pointer, because only a pointer can receive the address of the variable. Again, a and b, display the value of a and b 10 and 20. Now you call the swap one function with address of a and address of b. So a and b are actual argument. I'm passing the address of actual argument corresponding to the formal argument. So the address of a is received by p, means p is a pointer for a. Similarly, q becomes the pointer for b. So now within this function, I'm exchanging the values of a and b by exchanging the corresponding memory location. So now what happens? After coming out a and b, you will display the value of 20 and 10. That means in call by reference, any changes to the actual arguments are address. The formal arguments are pointer. So any changes to the formal argument inside the function has a direct effect on the actual argument. So if the formal arguments get exchanged, means actual arguments also get exchanged. So this is a major difference between a call by value and a call by reference. Last one is reference variable. How you can exchange the same two variable using reference variable. We know that reference variable is denoted by the ampersand sign. So here a and b are the actual argument, swap one function, address. So in the now note on the difference with these three. In the case of call by value, the actual arguments are normally integer. In the case of formal argument, they are the pointer. Whereas in the case of call by reference, they are the address, not address. The ampersand, any variable with the ampersand indicates it's a reference variable. So now the formal argument, one is a reference, p is a reference variable for a and q is a reference variable for b. Again, initially display the value of a and b, 10 and 20 is displayed. Then call the same function. Now here inside this function, you are exchanging the values of p and q. What are p and q? P and q are the reference variable for a and b. So whenever p and q gets altered, means a and b also gets altered, because in beginning only I told you, whenever a variable is altered, its reference gets altered. Whenever a reference is altered, its original variable also gets altered. So here what happens is, you are exchanging the values of p and q, which are nothing, p and q, which are nothing but the reference variable for a and b. So p and q gets altered, means naturally, internally, it changes the values of a and b also. Here the values again 20 and 10. So now I have exchanged two variable in three different methods: call by value, call by reference, and the usage of reference variable. But in your first semester C programming itself, you have studied in detail what is the difference between call by value and call by reference. So this is a third method of exchanging the values of A and B through the usage of reference variables. Let us see what is the difference between a pointer and a reference. Variable and its pointer will have different address. For example, int a comma star p. Next, then if you write p equal to ampersand a, means p is a pointer for a. So if the address of a is 1000, means the address of p need not be 1000. It will not be 1000. It will be some other address. That means the pointer will have different address. Its variable will have different address. Whereas a reference variable and the original variable will have the same address. Second one is you can declare an array of pointers. So you can have an array of pointer, but array of reference is not allowed. If you want to have 10 reference variable, in that case, all the 10 must be defined explicitly. Ampersand b equal to a, comma ampersand c equal to d, a, comma ampersand d equal to, like that. You have to declare all the 10 variables one by one. But if you have an array such type, you can array of pointer is permitted. Next, how do you access the value of the variable using pointer? You can access the value of the variable using the pointer using star operator, whereas the value of the variable can be accessed through its reference by giving the name of the reference variable. So these are some of the probable review questions on today's topic. What are reference variable? How do you declare and use them? Write a C++ program to illustrate reference variable. In what way a reference variable is different from a pointer? Let us take some simple multiple choice question. A variable and its reference has same address? Yes, the answer is true. Dash is an alias for a variable. Alias is nothing but alternate name. A reference variable is an alias for a variable. The correct answer is B. A variable can have how many references? A variable can have any number of references. The correct answer is C. Which of the following statement is wrong? A reference variable is an alias for original variable. It's a correct statement. Array of reference is permitted. No, only array of pointer is permitted. A variable can have any number of references. That is also true. A variable and its pointer will have a different address. That is also true. The correct answer is B. A reference variable is tied with dash variable. A reference variable must be tied with only one variable. That means one reference variable must be the reference variable for only one variable. It cannot be the reference variable for another variable. The correct answer is only one, A. Okay, students, in today's class, we learned another unique characteristics of C++ language called reference variable. A reference variable and original variable, they are one and the same. So you can call Rama by either Krishna or Krishna by Rama means Krishna will become the reference variable for Ram. That's all. So here, if ampersand B equal to A means B is a reference for A. That means either you can refer the memory location by either by A or by B. We also studied how to declare a reference variable and how to initialize the reference variable. What are the differences between a pointer variable and a reference variable? Hope in today's class we have learned all these things. Hope you have enjoyed today's session. For your queries and doubts, either you can clear it in your online Google Meet class or through any of these contact number, email ID or comment section in the Google class. Thank you.